Waves are produced in a long tank of water. The depth of the water, d meters at t seconds at a fixed location in the tank, is modeled by the function dt. So depth as a function of time equals m cos pi over 2t plus k, where m and k are positive constants. The figure shows the graph of d of t for t between 0 and 12, indicating that the point 2, 5.1, is a minimum and the point 8, 9.7 is a maximum. So you can see the minimum here, the maximum there. Find the value of k and the value of m. After t equals 0, find the first time when the depth of water is 9.7 meters, right? So in this equation, this is a general cos function. We have m cos pi over 2t plus k. So those things are doing different things. The pi over 2 bit influences the period of the graph, so it's a horizontal stretch factor. We've already been told that, but if we weren't told that, we could have worked that out. M affects the amplitude, so what that does, it stretches the thing vertically, right? So m will be the amplitude of this thing, and k, what that does, because it's after everything's done, that moves it up and down. So k is where the principal axis is. So the line y equals k is the principal axis. Principal axis. So what that means is it's the line that cuts it in half. So I'm going to try and draw the principal axis. So if it's going to look something like that, so it just splits it completely in half like that, right? So that is the line y equals k. So to work that out, well, we're going to have to use these figures here, the y values. So you know you have a maximum y of 9.7, a minimum of 5.1. So if you think about this, if we use these distances here, so this line here is going to be halfway between the 5.1 and the 9.7. So k is going to be the average of those two y coordinates. So it's 5.1 plus 9.7 over 2, halfway between. Well, 5 plus 9 is 14. 0.1 plus 0.7 is 0.8, so 14.8 over 2, which is 14 over 2 plus 0.8 over 2, which must be 7.4. So k equals 7.4. Now for m, remember m is the amplitude. When I say amplitude, it's the height of a wave, so the distance it gets from the principal axis. So if I can just draw a little arrow, this here, that height, that is the amplitude, so that is the absolute value of m, and we've been told that m is positive anyway, so that is just m. Let's draw that in, so that's m there. Okay, so if you think about that, well, the way we're going to work out this distance, we can work out the distance between the peak and the trough. So if I draw another arrow, so this distance here, well, that's going to be 2m. Let's just write that down. To work out m, well, we need to know the vertical distance between these 2 points. Well, that's, if you want to find the distance between two numbers, you take one away from the other. And then if I want to find half of that, I half it. So that means m is going to be, well, it's 9.7, that's the y coordinate of the maximum, minus 5.1, that's the y coordinate of the minimum, over 2. That will give me the amplitude. It will show me m there. So 9 minus 5 is 4, 0.7 minus 0.1 is 0.6, that's 4.6 over 2 must be 2.3. Okay, so m equals 2.3, and that is part A done, and then it's just asking me for B. So now if I just write down the actual function, so d of t equals m, so 2.3 cos pi by 2 t plus 7.4. And actually I probably don't need that for this. I could use it, but we shouldn't really need it. It says, for after t equals 0, find the first time when the depth of water is 9.7 meters. So if this 9.7 was not a nice number, so it's the maximum, then what I could do, I could use this equation and just set it equal to 9.7, try and solve it probably with technology. But seeing as 9.7 is just the maximum, the question really is, when is the first time when this will reach the maximum? You can see it happens here, right? And then we're going to use the period for that. And if you look at it, well, you can see that this distance here is 1 period, right? And you can, if you use the x distances, you can see that this goes from 2 to 8. Well, you think 1 period means 1 wave. It's the time for 1 wave, right? So if we go from the minimum to the next minimum, that's 1 period plus half. So 1.5 periods is the 8 minus 2. So if we do sort of 8.8 minus 2 is 6. That's 1.5 periods. So if we divide that by 1.5, or 6 divided by 1.5, what do you times by 1.5 to make 6? Well, that must be 4. But another thing we could have done, well, we could have worked out the period using what we were given. We were given the pi by 2. You remember, for sine and cos, period equals 2 pi over b, in this case b being the number in front of the t. So you could say, well, period equals 2 pi over b, which is already pi over 2. So over divided by pi over 2, which is the same as 2 pi times by 2 over pi, which is 4. So then it would still give you the same answer, because you're looking for 1 whole period from 0, it'd still be 4. So either way, that's the first answer. But like I said, if it wasn't a nice number, you would need to use this equation and solve it like that.